these docs up here. Main docs. Save. Fingers crossed. Hopefully this works. Not quite yet. So here is the workshop URL. I'm going to put that into chat. Boom. So check that out. Check out that repository. And then I will put my code up on the screen. Fantastic. All right, so here's the docs. If you want to follow along with the docs, here's the URL for that. I'll put that in the chat as well. So the repo, the docs folder in the repo just gets published to my website or to my URL. So there's if you want to follow along with the slides, that's what, whoops, not on the screen. Share. Entire screen here. That is what is on the screen now. So that URL is just DaShaun.com, Spring AI 2, M5 with Embabel 0.3.5. Why do I not? Where did everybody go? Oh, you're in this. Hold on, you're down here. I'm trying to figure it out so I can have both screens visible. So what I've done differently on this one. Wait,
all right, guys. Okay, it's already 8:05, so we will kind of commence officially. Okay, for those who are new here, if you are joining for the first time, please can you react with an emoji? Let me know that you are here for the first time. Anyone here for the first time? Okay. Oh, we have someone new in the house. Okay. All right.
Fantastic.
All right.
Welcome, welcome.
I can see that you are highly welcome. Highly welcome to this super section. Okay, if you were here in the previous section, please kindly react with your favorite emoji. If you are in the previous section, can you react with your favorite emojis?
Fantastic. Thank you, Precious. Prince
All
Will.
right.
We're good. Christy, thank you.
That's
awesome.
Great. That's
wonderful.
Great. Okay, right.
Okay.
Yeah, without wasting much time, right in our midst, we have Mr. DaShaun, a Java developer advocate.
So happy to be here.
Yeah, so this is a continuation of a last month's section on the topic covering the self-hosting agents, architecture, autonomous AI with Spring AI and Ollama. So you are highly welcome. If you are here, feel free, relax, and kind of get focused to follow along on what he's doing. He's one person that will always make sure that everybody is carried along. Sure, it was fantastic in the last section, and I guess today's is gonna be super, even more super than the previous one. So,
I hope so.
Once again, I welcome you, Mr. DaShaun. Thank you for your passion and the enthusiastic spirit in leading this very group up till the time of inception to this very moment.
Yeah, teamwork makes the dream work.
Yeah, sure. If you are here, I'll kind of applaud you for making our time to be present. And at this moment, at this very point, I will allow Mr. DaShaun to kick off the section. So, Mr. DaShaun, you are highly welcome. And at this point, you can take off the floor.
Okay, thank you so much for that. For those of you that we haven't met yet, I've been in this role as a Spring developer advocate for 1,595 days. Before that, I worked at a company called Redis. You'll see I like Redis, and we're going to put that into the workshop. Before that, I worked at Pivotal, and I was on the architecture side. I was also a VP of engineering. So I've been in the role where I was in charge of engineering. And that means the infrastructure and the apps, all of it. You know, the cloud span, getting features to market, that was all my responsibility. And you'll see some of that come through in how I present. And before that, I worked at Garmin. I worked on Garmin Connect. I was their lead, and it was fun. And you can find me on all the places. Most of you have, and I appreciate that. I do Spring Office Hours. That's a fun show. If you want to keep up with what's going on, check it out. It's available as a podcast. So if you don't make the live show, you can come in and see. This is a picture of my family. When you come to my house for dinner, if you leave hungry, that's your fault. I'm not on a mission. I don't care if I finish this workshop or not. My number one goal is that everybody here learns something. So if you got questions and you don't ask, that's your fault. I want you to ask questions. If I'm moving too fast, raise your hand, slow me down, because I'm happy to come back. I want to make sure that everybody is able to consume what we're going through and understand it. That's more important. So if we don't get through everything, that is fine. I want you to leave here learning something, okay? So don't leave hungry.
Great, Mr. DaShaun. I'm already hungry right now.
All right. So I'm going to do kind of a quick recap because some of you weren't here the last time. We're doing Spring AI and agents. The whole idea is I believe that a lot of us, most of us here, are going to be not just writing code, but we're going to be creating agents that are going to do some of the work for us. They're going to do simple things like code reviews and pull requests and all that kind of stuff. So this workshop is to show you like a hands-on, it's a 100 level, but it's connecting the dots and doing all the things that the agents that you pull off the shelf, the open codes and the Claudes. I'm going to show you that we can actually build an agent just like Claude, just like Copilot, just like Codex. We can build our own agent, give it our own rules with Spring AI. And for the second half, we're going to use Embabel as well. So again, hopefully you've checked out the stuff. Here's what we're getting into. We're going to build a little AI agent sidekick, just like you're used to use or you've seen your friends use. We're going to build it from scratch because you have that power. So this is going to be all running locally. We've picked a model that gives us the tool calling capabilities, and it's fairly lightweight. So we're going to do this. Hopefully you can run it on your laptop. Last time I did it on an 8 gig, this machine right here, because I just walked through it again. It was a Microsoft Surface that only had 8 gigs of memory and no GPU. And today I'm still not going to turn on the GPU. I'm going to run it just like you so you can see these models are actually really, really powerful. And you don't have to have the frontier models in order to do some of this work. So we're going to ask questions, we're going to do RAG, we're going to do this multi-step agentic workflow, and yeah, we're going to do some cool things. So no cloud, no keys, everything's running locally, just the way that I expect it. We're not going to give any more money to anybody that we don't have to. So here's what it looks like. We've upgraded. Oh, I'm embarrassed. We're going to switch this real quick because Spring Boot 4.0.6 is out, and this could blow up everything. It absolutely could. So we're doing this. We're not going to use 4.0.5. We're going to change that, but we'll come back. We're going to change that to 4.0.6. We are still going to use Spring AI 2.0, M5, and Embabel, the latest version. I think it's only 3 days old, of 0.3.5. Now, Embabel hasn't caught up to the Spring AI 2.0. So when we do switch to Embabel, we're going to be using Spring AI 1.1. But that's okay. We're going to take all the benefits that Embabel gives us, and yeah, we're going to be just fine. We're using Ollama. We're using this Qwen 2.5 Coder 1.5b. And we have our embedding model, and we're going to use Redis for our vector database. So what is Spring AI? Spring AI, again, is that abstraction. I'm going to draw a quick picture. It's the abstraction on top of AI, Gen AI models, just like Spring Data gives us the abstraction over Postgres, MySQL, Oracle. We have all the things. We have the nice abstraction so that we can get the 95% of everything that we need from whatever database. We can do the same thing from whatever model. We can get all the features. We have that abstraction later, and we can switch models easily without changing our code. So yeah, right, once swap models freely, we are going to use models running Ollama. Ollama is to models like Docker is to containers. We can pull these models down from everywhere, from Hugging Face, from Ollama. We can pull these models down and we can run them just like you do with a Docker container. We're going to have it auto-configured with Spring Boot. And we're going to use this advisors API. This is the functionality that, again, Spring provides as a wrapper around the types of things, the implementations, the patterns that you're going to see when you're doing Gen AI workflows. We're going to use tool calling. That's our name for doing MCP, the Model Context Protocol as well. And we're going to show structured output. These are just some of the things. So we're going to go kind of quick because last time we did run out of time. What's Embabel? Embabel builds on top of Spring AI. Embabel there's two main things. Embabel is really focused on limiting the determinism, making it more deterministic. So it uses that structured input and structured output to make sure that your chains are consistent. One of the biggest, hardest things when you get to production at scale and when you're developing agents, you don't want agents going off the track. So with Embabel, we give it these well-defined guardrails by using the type safety that we get from Java, and it builds on top of Spring AI. So Embabel is actually created by the founder, the creator of Spring as well, Rod Johnson. So this is just kind of a natural, and you'll see the idiomatic ways that Embabel feels like an extension of Spring. So yeah, one of the big things is it's goal-oriented action planning. So you can provide these different actions, and what Embabel will do is it'll find the route between the actions that you've defined. It'll find the possible routes to the goals that you're trying to achieve. And we'll get into that a little bit more. Again, the Java types, deterministic by design. So we're not scripting workflows, we're declaring goals. So we're going to jump into these labs. I'm going to go through labs 1 and 2 pretty quick because we already did those last time. But we do need Java 21. We do need Docker Compose. We do need at least 8 gigs of RAM and some IDE. So your first step is to clone the repository. I'm not gonna give you a whole lot of time, but I do want you to keep up. I want you to clone this repository, and I want you to, try to play along, but I'm not gonna stop unless you raise your hand. So I've got it cloned, I've got it pulled down here. Then we're gonna go into the infrastructure. We're gonna stand up these models, and this is the part that might take a while. So in your IDE, I want you to cd into infra and Docker Compose up. You can do -D, it'll run in the background. So it's going to pull down the model. So I removed some steps. It's pulling down this model that has our models already pulled in. So this container that we're using actually already has Qwen 2.5 loaded, and the nomic embedding model is already loaded. So once you pull this down, once this starts up, you have everything that you need. We don't have to pull down anything else. So it's like a 4 gig download. So it might take a few seconds, minutes, maybe, but that's it. We don't have to do these steps. Ignore this part. Fix that in the docs. All right, now we're going to verify this infrastructure. We can do a couple of things. I'm going to do Docker Compose PS. Make sure that I can see that I've got my test container running and my Redis stack running. I'm also going to go up here and I'm going to run this command. I want to see the models that are running inside of that container. So I'll put this into the chat. Once you've got your Docker Compose up, this is the command that I want you to do. That command is going to show I've got the models are already there, right? Again, and those models are pretty small, 74 megabytes, 986 megabytes. This container is actually using Ollama 0.22.1, the latest Ollama container as of a few minutes ago. So now I've got my infrastructure up. I've got a Redis stack. I've got a model that I can talk to. Now let's get started. We're going to go into our labs. We're going to go to lab 1. And I'm just, again, this is a review. We did this last time. We can see Redis is there. Lab 1, just stand it up. We can test. I've added test containers. It's going to use that same thing, nvnw test. Let's make sure that everything's rocking and rolling. Again, you might still be downloading the containers. That's okay. But I've got some tests. Things look good. So with that, let's go take a look at lab one. This is just the simple stuff, and we're not going to do the exercises for lab one. I want to remind you, for those that weren't here last time, this abstraction, what we're doing here is we have a chat controller. This is simple. This is regular Spring ABC. But down here, this is the main thing, is this chat client. This is the way that we interface with our LLMs. The chat client is like your JDBC connection pooler, your JDBC connector. So this is how we're going to interface. What we've done here first is we said, hey, you are a helpful Java developer assistant. You give concise, accurate answers with code examples and appropriate, always use modern Java idioms, records, pattern matching, etc. So let's just run that. NAIJA-JUG, Spring, boot, run. We have another endpoint down here, the chat endpoint, that we're just going to hit it. So we're going to hit, which port did I run it on? What you build, it's running, we're doing things. Hey, we already showed this example, key concepts, fantastic. This is what we just looked at, the system prompt. We're going to call the LLM. Here's our chat endpoint. What we're doing here is we're pulling in that chat, the chat client that we already defined in our constructor. We've already given it a system prompt. So we said, this is how you're going to behave. And now we've added one little thing, hello. We have a default prompt. So this is the user message that we're sending to that LLM, but it has these instructions that go along with it. So we're going to hit that chat endpoint. I think I changed the port here. I didn't. So localhost 8080, chat. All we said was hello, and here we go. How can I assist you? Lab one, easy. We are talking to that model. That's the big thing. That's the part of lab one. It's like, hey, we can use Spring AI interface. This doesn't just have to be your agent. You can have your production systems that are interfacing with this model for different tasks. So let's quickly move on. Again, we're just kind of reviewing. We talked about the prompt, the difference between the system prompt and the user prompt, right? Hey, this is how you're going to behave. This is what I want to ask you. We made the call and we got the content back, and we just showed the content on the screen. Our config, we look at the application YAML, our config, we're hitting localhost because we've exposed that. That's our Ollama server. Here's the model that we've chosen. We already had that configured inside of the Docker image. And here's a couple of options. These options you can tell the model, I want you to be very focused, don't be creative, or hey, I want you to be creative with your answers. Don't give me the same answers all the time. This is that non-determinism that LLMs are known for, right? We want it to be conversational. It's using statistics, right? If I ask it this, statistically, they want to see a response like this, right? Gathering those weights. The model is trained on the internet. But this one is structured. And this model is, in particular, designed for coding, right? So I don't necessarily want to ask this model for translating English to German or apple pie recipes. This model is particularly good at tool calling and coding tasks. But you can switch. So we went in, we already ran that, and we hit that local AD. We can ask more important things. We can ask it to explain things, but we did that last time, so we're going to go ahead and move on. We did this chat. We asked it, we said hello, and we moved on. So if we want to do something extra, I can do this one. I'm going to jump over here, and I'm going to show like, hey, it doesn't just have to say hello. So this is hitting that localhost, still 8080 chat endpoint, but it says now explain sealed classes. Same thing, that model should still be running. Did I put something there? So far, so good. I don't see any hands. Good. Give me a thumbs up if you've already pulled the model down. You've already did your Docker Compose up and you've got the models pulled down. Give me a thumbs up. So here's the explanation of sealed classes. They gave us a nice full-on explanation with code examples. So that was pretty nice. So we're talking to our model. Remember, this model is code task friendly. And we told the model, we said, hey, you are you are a helpful Java developer assistant. So it pulled all the information that it knows about Java when it gave us our response. So instead of just saying hello, we passed in that message that said, tell me about sealed classes. So we can move on. So now we can modify the system prompt. This is fairly easy. We're going to make the assistant respond as a pirate. So the language, the words that it's using, we can tell it to change how it talks. One of the popular recent ones was talk like a caveman. Respond like a caveman to save tokens so that we're not sending back as much text. So let's just go in and do that real quick. I'm going to close this. Boop. Control C to stop. I'm going to make one quick change to my system prompt. Right. I'm going to change this system prompt to another system prompt that is the exact same. And if you checked out the repo, it should be as easy as this to make the change. Trying to make it easy so that we can move a little bit faster. All we did was change respond in the style of a pirate. Let's start it up real quick with those new changes. And I'm going to do this one for speed. So we're just going to say hello, but it's going to respond in the style of a pirate. Ahoy there. What be ye seeking? So that's as easy as it is. We changed the system prompt. We changed the way that it's going to behave to get the right language, right? If you're running a business or you have a brand, you want it to speak in your brand. So that's what we've done. Fantastic. Let's keep moving fast. I think we're doing really good for time. We restarted. We can add and explain endpoints. So if we want to get like specific concepts, we're going to skip this part, but we can see we're going to change the system prompt and we're going to add some text, explain the Java concept. So this endpoint, all we're going to do is pass in a Java concept and it'll give us that same output. But we're going to skip that. We've already talked to the LLM and we're going to scoot through that one. But Spring AI makes LLM integration feel like Spring. This chat client builder is the autoconfig, right? That's our interface, just like our database connectivity. System prompts change the personality, right? The brand, the style. Without changing code, Ollama runs everything locally. Again, we're not burning any tokens. If I was running this on a Raspberry Pi, I have unlimited tokens, not the same speed, but unlimited tokens. That's the big trade-off. And models have a cutoff date. So watch this. That's one I didn't cover, but the models have a cutoff date, and I can ask that model. See this, and I'm going to say, hey, model. What is your data cutoff date? The model is trained. It's not recalculating and reabsorbing. This model, Quen 2.5, is not learning anything. It's been trained on data up to, maybe I've seen bytes and not a timekeeper. I don't have a specific cutoff date like humans do. However, I've been around for a while. I should be pretty accurate when it comes to nope. I think this model was 2023 with its data up to 2021, but it's got a cutoff time. And that's important, right? The models have a cutoff time. So it's important to know that they don't have all the information. That's why I brought that up. They don't have all the information, but you can still use the model's capabilities by giving it more information. So after we got to through the whole chat thing, the next step, the next phase of AI, Gen AI workloads was this retrieval augmented generation. Thank you. Retrieval augmented generation.
Yeah. All right. Mr. DaShaun, please
Yes.
allow me a second. Yeah. Please, if you are just joining for the first time, and we have our channels, the links to our various channels has been dropped in the chat section. You can just go through the message section. You can find the links to our the WhatsApp group, the LinkedIn page, the X Twitter. You can just follow us along and stay tuned to what we are doing. Please do check the message section and follow up. Thank you very much. Yeah.
Fantastic.
Mr. DaShaun, I also want to ask if you want to, would you like to kind of allow message questions in between, or you want to finish before?
Yep. Ask your questions. Ask your questions. If I'm going too fast, raise a hand, throw something in the chat, because I'll stop.
All right, guys. All right, guys. Please, if you have any concern, please, you can just indicate why we are going. I think he will be able to answer you while we move along. Thank you very much.
All right, fantastic.
I think that's all. Yeah.
We're moving on. Right. Again, this is kind of a repeat of the last time, but I think we're going to be okay on time. Lab 2, we're doing the retrieval augmented generation. Whoops. So let's go and run our tests. So here, we're going to stop. We're going to get out of lab 1. We're going to go to lab 2. Again, you've got this code, the repository is out there. Let's make sure things are working, tests are passing. Again, what these tests are doing is it used test containers to stand up that model to run my AI tests, and then it'll tear it down. That's one of the other benefits of Spring. This nice test containers integration makes it so I don't have to have infrastructure running. I can go and shut down that Docker model. Actually, let's do that. Where we have the infra, right? We stood it up. I can go Docker compose down. Hey, let's stop it. I can run these tests again. So right now, Docker PS, there's nothing. Whoops. Oh, wait. There's other stuff running, but not my Ollama. I got other stuff on here, which I'm surprised by. But Ollama's not running, but I can still do my MB&W test, because what it's doing, it's standing up that model. It's already pulled it down. It's going to stand up that model, make it available for my tests, and then it'll shut it down. So just to show you, like, test containers, so that you can validate, you can have these nice integrations. But what you don't want is you don't want to have all of your models running for your test pipelines. With test containers, you can validate your Gen AI workflows, your LLM Spring AI workflows. With test containers, it already has the model that we want to use in production loaded. So it'll stand up that model, run your test, and then tear it down. So again, those things don't stay up. My Ollama is still not up. So that's a good thing. So let's go back. We're going to stand up our Docker compose because we're using it. We'll put that up in the background, but I just want to show you that my tests are using test containers. So now, here's the thing. It's up and working. We're good. Things work. It validates in some tests. So the problem with vanilla LLMs is, like, they don't know. What's our team's convention for error handling? It knows nothing about how your team delivers code, right? It didn't have access to your internal Confluence or other. And if you ask, it will hallucinate. Right? Remember, this is just statistics. It doesn't have the information. It'll guess at what that information might be. It doesn't know your code base. So this is why we get into retrieval augmented generation. What we are doing is we are literally taking information that we have that the model wasn't trained on. We can take some of that information and we can feed it to the model. So just like our system prompt, we said, hey, I want you to talk like a pirate. What we can do with Spring AI is we can give it this advisor, the additional information, and we can say, hey, before you respond, consider this additional information. Stuffing the prompt. So I'm giving it the extra information that it wasn't trained on in order to use that for its response. Let's walk. We're going to build it. We're going to ingest a doc that's already there. We're going to use that document's information to give us our answer. So this is what it looks like. We're doing the documents. It's going to chunk those documents, turn those documents into embeddings. And those embeddings are going to get stored in our vector store is Redis. And then we can query. When we ask the LLM for more information, we're saying, hey, LLM, there's some information over here in this vector store that might be beneficial, and we're going to stuff that into the prompt. So here's the key concept, this document ingestion. We're going to ingest the document. This one is just on the class path. You can feel free to add more information there. Any docs, as you can see, any docs that are in this folder, they're going to be ingested just in a regular loop. Here, grab all the documents. Yes, go ahead and ask your question. And then parse the document. Do the embeddings. Do the split and store it in the vector store. So here, we're going to look at lab 2. We're going fast. Here, source, main, Java. All right, here's our controller. We're looking hot. It's a regular Spring Boot app. Regular Spring Boot app. We've got some config over here. Here's how we're going to handle our config. We're saying, hey, now we're doing retrieval augmented generation, not just chat. So here, the additional thing that we're adding is, again, same. You're a documentation assistant, slightly different system prompt, but you've got additional information. I'm giving you this question and answer advisor. I'm giving you this ability to go and look at this vector store. Use the vector store. And then our application over here, we've configured our vector store. We're going to use Redis. We're pointing to Redis. That's the easy part. And here, we're setting up our RAG chat client. And down here, we're saying, hey, we're going to ask a question, but I also have my ingest. Wait, that's the URL one. Where's my regular ingest? Here we go. Here's my regular ingest. I'm doing my build splitter. That doesn't match the docs. But here's where I go through my class path. We're going to ingest all the documents that are in this path. I'll show you those documents here. So this has a Spring Boot conventions markdown file. So when this boots up, when this application boots up, it's going to grab all the resources. You can put your own in there if you want it to parse another document to do a slightly different one. Go ahead and do that. But this is what we're doing. We're going to parse all the documents that are in this folder, and we're going to store all of those documents into our vector store. So now those documents, the embeddings, the floating point vectorized information from that document is going to be in that vector store. So let's start it up. W, Spring, run. It's running. Oh, there's an error here. Oh, that's safe to ignore because I'm on a Mac. We see it ingested the document, right? That happened as part of the startup. It ingested the document. We're in good shape. Let's continue. We've done these steps. This code doesn't match what's in the lab. I apologize for that. But here's the key concept. We have that token splitter. We can decide how big the chunks are going to be and lose a little bit of relevance, or we can have it fine-tuned. But that really depends on the document that you're ingesting. We're not just going to say, hey, go grab that document. If it's an encyclopedia, maybe the relevance, we need it to be smaller. But it depends on the document. It depends on the type of data that you're ingesting, on how big you want your chunks to be. Because again, if the chunks are too big, then you might not get the correct answers. You might not get the specific answers that you're looking for. But if they're too small, you might miss the additional context around that chunk. So this is just how you're going to fine-tune that embedding, fine-tune how tight or how specific you want your answers to be. But again, each document is different. So you'll play around with that. Chunk size, tokens per chunk. Too small, we lose context. Too large, it's diluted relevance. Again, we're going fast. So now we're going to do this question and answer. So now when I ask, we already looked at this RAG chat client. When I ask, it's going to use this question and answer advisor, look into our vector store to get the answers. So we've got this ask endpoint. We can ask it a question. And again, all it's doing is using that chat client. We're going to pass in a question. Easy enough. So we've already done the starting up. And now we're going to ask a question. What are the testing guidelines? Easy peasy. I'm asking, what are the testing guidelines? Same model, but this model didn't have our testing guidelines before, but we've given our testing guidelines here. Unit test, use JUnit 5, Mockito. See, it was able to pull that information from our specific document, and it used this document to answer the question. So that's pretty awesome. it was able to find it. If that document was bigger, it would find it as well. But your next step, if you're interested, is grab another document, grab a markdown, grab a PDF, and throw it into your docs folder, and it'll automatically be ingested. But the next step of that exercise is like, hey, having docs on your file system, that's not great. If you're trying to do something new, if you're trying to understand Spring AI 4.1 that's coming out, no model is trained on 4.1, but you can feed it that information. So the next step of this exercise was go out and ingest with a URL. So pass in a URL. I want you to ingest this URL and then use that URL. Use the information that you ingested to help me answer my question. This is where things get really interesting, because this is where I've now got this agent that isn't just focused on the stuff that I have on my laptop. It can go and grab stuff from the internet. This is cool. So let's do that real quick. We're going to go and uncomment a few things, because now I'm changing this ingestion service. I want to bring that ingestion service into my controller. Here's my ask. And now I'm going to say, hey, I'm going to add one more endpoint that says, hey, I want you to ingest a URL. So when I call this ingest endpoint, I'm going to pass in a URL so that it can do that before I ask my question. I'm going to ingest it. It'll check if it's a valid URL, but it's the same thing. After we get our information, it's going to go back and do that. Whoops. Oh, sorry. Oh, it's over here. I have one more change to do. I'm adding this one endpoint that's going to pull in that URL. So here's our ingest URL, pass in the URL, figure out everything that's in it. Kika's going to chunk it, and then we're going to ingest it and store it here, right into our vector store, just like we did before. But it's not on our file system. We can give it any URL to go in and throw into our vector store. So we already did these steps, and we can say, hey, go ahead and ingest this URL first. Ingest this URL. Oh, I didn't reboot it. Please hold. Hello. Boom. With our new endpoints that we just added. Reboot it. Uh-oh, what did I do? Cannot find symbol URL resource. All right. You're supposed to be playing along. What do we do here? Document ingestion service here. Oh, is that not? Please hold. This is the easy part. Why isn't it complaining? Please hold. Let me see what I can find. I can't see that screen all the way up there. Any questions? This is a good time for questions. Ask them. What did I miss?
Hi guys, please do ask your questions in case you may have any concern. Thank you very much.
Anthony, what am I missing? I think it's just an import, but why isn't it showing? Can't find declaration to go to.
Yeah, I'm looking at my phone. I've been following.
I appreciate you for being here. So I'm missing an import URL resource. And because I had the way the lab is set up, it's like, oh, I don't know where my root is. Please hold. I don't know it off the top of my head. Is it java.net? But it doesn't have any of my stuff. Why is that? Why is this class not loading? I think it's just java.net URL resource. We're going to try it. And if not, that's okay. You are playing along. Your IDE is playing nice with you. Oops, what do we here? And I'm guessing, I think that it is. And import java.net.url resource. Let's try that again. No, that's not it. Cannot find symbol. Response entity. Oh, come on now. That's frustrating. This should have automatically happened. Import org spring framework.web. Not a git mapping. It's not an annotation. Please hold. I need a Spring response entity. Just need to find that class path. Please hold. Please continue to hold.
Can you just go to your doc agent controller class also? And
Say it
also, your doc agent controller class, they said the response entity is missing.
Yeah.
So
this response entity. So when I did my comment,
what I'm thinking is that currently your project isn't built properly, or so.
Yeah. When I uncommented things.
So let me see. I'm coming.
We'll fix this. This is par for the course, right? Things don't always go the way you want them to.
I think
and I just don't know these things off the top of my head.
Spring framework.
Yeah. All right, we're getting there. And what's the last one is URL resource.
Does your project use Maven?
Yes.
So you rebuild this completely from on the right hand tab.
Yep. The reason why it's not working like that is because I've got multiple projects in here. So I've got multiple Maven paths in there. So that's the reason why it didn't work automatically.
I see.
So we figured it out. Oh, I thought we figured it out. Class malformed URL exception.
Currently, it's all your project that is not actually built. Everything is affected, not just one.
What's the last one? Cannot find what symbol? Malformed URL exception. Did I just add that? Oh. Oops, no, not that one. Java.net malformed URL exception. Okay, so that was like a 5-minute nope, and plus more post mapping. That's a fail. Like I said, I was making changes to this right before I got on the call. That is a character flaw, but we are going to catch up. This is just step 2. Lab 2. Moving on. We now have an ingest. Oh, come on. What else are we missing? Another malformed URL exception. Java.net.malformed URL exception. Please work. My credibility has been tainted, but I'm not going to panic. What now? It says cannot find a symbol document in, oh, I got it. The document ingestion service is not in the same package. Here, import com.workshop.lab2.service.document and yes, service. I was trying to make it easier. Variable ingestion service might not have been initialized. Oh, because I got to add it here too, right? Document ingestion service. We're getting closer. But the thing is, like everything here, that was Spring. That was a failure on my part where I tried to make this workshop super easy to do. But now I'm confident you can follow along and you can do this. All we did was add a method to ingest from a URL. So now we can go over here. Let's grab my, hey, do this ingestion. Give me this stuff. That endpoint should exist. Ingestion failed. No. What did it? 500. It said what? Ingesting URL. Wait, what? 0-byte file exception. Oh, I think that was it. Ingested 2 chunks stored in Redis. So that document, it went out and grabbed Spring.io. I was missing the S. It went out and grabbed Spring.io and it stored it in Redis. So now we can go look and we can see that our little vector database, localhost 8081, wait, what port did I put Redis on? Infra. I put Redis Insight. Oh, I didn't provide a Redis Insight. Oh, here, 8001. So this is just to go look at our vector store where we have everything is there. Like, hey, yeah, cool. I've read it, understood. So here's all of our data. Here's our embeddings. So that's the document that we loaded from the class path, and that's Spring.io. So now that that's been ingested, I have the information from Spring.io. Now I can go and say, hey, what can Spring do? And my LLM is going to know it. It probably knew it beforehand, but it's going to use this information that we just got. What can Spring do? Because it has that question and answer advisor, it's looking in that vector store and it's pulling information out. That was like a 10-minute distraction. I apologize for that. What can Spring do? This question, remember, it's going to go and ask. It's going to go look in the vector store, and it's stuffing all the information that it gathered around Spring. It's stuffing that in the prompt to get its response. So And we got a nice long answer. So here's what it learned from the URL. It went out and grabbed the information. We did the ingest part. It went out and grabbed the information, and it provided what can Spring do? A wide range of things: microservices, reactive, cloud, web. But it got that information from the website. But this could be from anywhere. This doesn't have to just be a website or a document. This could be from a data store. It could be from a database. Again, Spring AI makes it easy to connect these dots. You cannot do AI without data. We're moving on. So now we've done retrieval augmented generation. We've ingested docs. We're doing cool stuff. Here's the key takeaways. We can do it with our own data. The question answer advisor that's the key for doing it. We used Redis to do our vector store, and our controller code is identical. The RAG is invisible, so it's easy peasy. Now we're going to build an MCP server. So last time I had us pull down a NPX server. This time we're actually building our own MCP server. So everything is Java. We're not pulling down a node service. Everything is Java. So let's jump in. So I'm going to go back. We can clear this one. We're going to go here. We're going to close lab 2, and we're going to go into lab 3. And this is our MCP server. So let's quick do our test, NAIJA-JUG test. Make sure everything is up and up. Fantastic. It looks good. This is an MCP server. Let's go take a look. This gives us the ability. This is the model context protocol. This is what's going to give us the ability to have agents use tools. The one that we're making here, this MCP server, this is for editing files on the file system. Or a file system tool. I'm going to make this small. This is the new stuff. So if you're following along last time, now we're into the new stuff. So now we've got a file system tool. We're creating it to follow the MCP protocol, the model context protocol. And what that's doing, it allows our tools to get some of that information. Just like we stuffed the prompt for our retrieval augmented generation. Now what we're going to do is we're going to provide context around what we're doing. We're going to provide that to a tool. So we're going to be able to say, hey, I'm working on this code. Here's the code base that I'm working on. I want you to make some changes. And we're going to give that to the tool. Please do that for us. Just like you have, we showed kind of an example of go get me some information from the web. We could turn that into a tool, but this time we're going to say, I want to make changes to the file system, and this is what it looks like. So we're just making a component. We're giving this component a workspace path. So in this folder where we're at, sorry, let me go down here. In this folder, /workspace, this is where our project is. So I'm saying, hey, you only have access to this workspace path. This sample project is where it's going to make its changes. This is how we identify the tool, how we're setting up the tool. This annotation says, hey, list all the files in the project workspace returning relative paths. Fantastic. It can get an understanding of what files are in the space. Let's scroll down. Read the full contents of a file in the workspace. You see what we're doing is we're giving this tool, this file system tool, we're giving it separate tools, even though it's just one MCP server, we're giving it separate tools to use to make changes to this workspace. This is an example of a MCP server. Finally, we're giving it the ability to write contents to a file in that workspace. Pretty straightforward. At this point, the MCP server is just doing simple file I/O, right? List files. So that means this will work. Java's right ones run anywhere. This will work on whatever operating system we want it to run on. So here's our MCP server. It can resolve some paths, right? That's a private method. Let's go and make this run. You can see MV&W, bring boot run. So we have an MCP server that now is providing access, and it's exposing these tools to make changes against this workspace, right? You don't want to give, maybe you saw the news this last week, you don't want to give your agents access to everything, because last week there was another company that they gave their agent the ability to make changes, and it also had the ability to go in and delete the production database. What we've done here is we said, hey, this is the only spot that you've got access, where we're giving it guardrails. So this agent isn't going to delete our production database. This agent only has these tools available to it for this path on the file system. Fantastic. So now we've made it, we've done it, we validated it. Here's the story. We can talk to the LLM, we can ground it with our own data. Now we're giving an agent tools to act on our file system. So I could make it pull things from GitHub, but the idea is I want it to have a focused intent. So this MCP server is just for a specific workspace, but that could be configurable, right? I could give 20 different agents, 20 different paths to work on. So what is MCP, Model Context Protocol? I think I already went over it. Any LLM can be an MCP client. Any backend can also be an MCP server, right? It's using standard JSON over HTTP. So this says in Lab 5, your Embabel agent will call the server that we just built. So why build it in Java, right? The last time I was using NPX, I was grabbing one off the shelf. But the whole idea of this workshop is you can build all of these things in Java, in Spring. Spring gives you the tools. Spring gives you the abstractions to do all the things that you see all the agents doing. But if you're a Java developer, like most of you are, this just makes it easy. You can do it in the language that you prefer, and you can have all the same functionality. So this works, but it adds Node.js and NPM. We don't want to do that. So now, and that's what I did last time. So now we have less prerequisites, right? All we need is Java. So we're pulling it in. We've added this one dependency, pure Java. So now it has the ability to go and read and write to that file system. The MCP server autoconfig picks up the tool callback provider bean and exposes its tools over streamable HTTP. So it's not a pause and wait. This is going to be as fast as possible. And we already went over the tool methods. So I showed them all. The list files, read files, make changes to the files. Writing tools. Again, we already peeked at that code. It's that simple. So the config, let's go quick and look at the config for standing up this MCP server. So, hey, here's our name of the application, but we're adding Spring AI MCP server. This is how we're configuring it. This is the name. Here's the version. And that, again, that's part of the MCP specification. And here's what type of interaction is, right? This is streamable, so we can do kind of async conversations. Here's our properties for the workspace. And this is going to start up on port 8083. We're telling Tomcat not to use relative redirects, and we have a timeout set. Cool enough. So our application is up and running. We are exposing an MCP server. We are in good shape. So hands-on, we've done it. We started it up. Let's do this thing. Verify the server is advertising its tools by performing the MCP initialization handshake. That seems pretty crazy, but we can do it. Like it, I'm going to scoot past it. Or no, I won't. Whoops. Let's do that command just to make sure that we're doing the handshake. Copy all the things. Let's make sure that it's speaking MCP. Run that. Localhost 8083. Let's make it look a little bit prettier. Let's do it this way. And we're going to pipe that to JQ. So we get a nice formatted JSON, and we can see, hey, here's our MCP server. Here's the version. Here's the tools that we have available. And we're in good shape. We are speaking MCP. Congratulations. Fun fact, the Spring team developed and is maintaining the MCP SDK for Java. They immediately contributed that over to Anthropic, the creators of the MCP protocol. So now we can add this create directory tool. That's cool. I think we can just copy and paste that if we want. I don't know if we need it, but let's try it. Let's add this create directory tool. Not in here. Here's our tools. We're going to add a create directory. Boop. Create a directory and parent directories in the workspace. Boom. Pass in your directory, pass in the path, and let it do its thing. So we've just added a tool. It's that easy. In your W Spring run. Have any imports to pull in? No, we're in good shape. All our file system IO, we've kind of rounded it out. With now it can not only just edit files, but now it can create directories as needed. We're going to leave this one running. I'm going to rename this one over here. I'm going to rename this session. This is our MCP file system. Okay, so that's running on port 8083. It has access. We've got an agent that, or an MCP server that has the ability to make edits inside of our workspace. It can make edits in here. We're going to leave that running. Boom. Key takeaways. Spring AI's MCP server starts, turns the Spring Boot app into an MCP server, following the MCP protocol, providing services to LLMs. Tool calling LLMs. Qwen has the ability to use tools. Not every model does, right? If we go back to ChatGPT 2, it didn't have that tool calling capability. MCP protocol came out in November 2024. The Spring team added the MCP SDK in, I think it was January 2025. And then we heard this big wave of MCP and tool calling, giving these agents additional tools to call things, to do deep research, go grab URLs, make edits to file systems, etc. Delete production databases as well, right? I showed how the tool callback provider is the bridge, how we're exposing the MCP server. Path sandboxing is your security layer. We said you only have access to this folder. So Lab 5 is going to call this, but we don't have any node NPX. We have to move on to Lab 4. Agentic workflows. Now we're using Embabel. We're going to stop scripting workflows and we're going to start declaring goals. Now we're getting into the good stuff. So just a quick reminder, Embabel 0.3.5, the version that we're going to use, it's not upgraded to Spring AI 2. So in this folder, we're using Spring AI 1.1.1, and that's okay, right? It's still going to work. It doesn't matter that we're using Spring AI 2.0 for our MCP server, because the MCP protocol is the interface. I just don't have the access to everything that was provided, added into Spring AI when I'm using Embabel. But it'll come eventually. I'm adding Embabel to these workshops because of its fixing the determinism. The things that we're trying to do, the things that if I was using Embabel and I was making edits to a file system, or even if I have it deploying code, with Embabel, I can give it stricter roles. We'll see that in a second, so that it can't delete my production database. I'm going to close this. I want to make sure that I'm still seeing. Are there any questions in the chat? I don't. Is the repo accessible? If yes, can I have a link so I can? Yes. Thank you. So that's the URL. Let me grab the URL for the repo real quick. It's up higher in the chat. So this is the GitHub repo. Can I just pin that? Pinning messages, pin this message. So I pinned the message. Now everybody can see it, but I'm going to put it back in the chat as well. There's the code. That's the code base that you want to check it out and follow along. That's where we're at. And man, look at Anthony's woman. That is a good looking couple. That's a power couple if I've ever seen it. Sorry about that. We are doing good things. Let's go. Whoops, sorry. I want to go back here. We're going to continue going. We are going to validate. So let's go to our Lab 4. We're going to make sure that it's up and running, that we didn't break anything. What Lab 4 is doing, remember this is Lab 3 that's running. We're going to go here to Lab 4. In Lab 4, we're going to, first thing, let's make sure that everything's working. That's safe, right? When you check out code, make sure that it works, right? I don't want you to have to go through a bunch of troubleshooting like we did a few minutes ago. Please work. Remember, this is standing up that test container so that this Embabel workflow is using a model to validate its tests. I can switch the model, and this is a good way of validating, hey, if I upgraded from Qwen 2.5 to Qwen 3.5, do all the things still work? This is an important step. So I use test containers to validate that things are still working. So yeah, we should be on a good path. So now the things that we've done so far is we've talked to an LLM. We've fed LLM additional information using that retrieval augmented generation. And then we stood up an MCP server that can make changes to our file system. What we're going to do here is I want it to do work. I want it to do specific work. So I'm going to close these guys. We're going to open up lab 3, close all. We're going to go into lab 4. What lab 4 is doing, these are the agentic workflows. This is where I'm giving specific things, not just allowing, hey, give me the a recipe for apple pie. This is a code review agent. This code review agent has specific, oh, and my labs, I need to update. Why is this? All right, I got to update some stuff. I was making lots of changes. Our agent config is here. Here's our REST controller. We're going to still have endpoints that we're calling. We're bringing the agent platform for the config. That's Embabel. And here's our map. We're just doing one endpoint that says review code. So that's what this guy is doing. Let's scroll down here. This is our code review agent. Here's the description for this agent. Reviews Java source code and produces a structured report. Fantastic. That's what we want. It's got actions defined. Just like we defined tools, now we're defining actions. This agent can only do these actions. Analyze Java source code for quality, bugs, and style. And here's the achieves goal. Produce a human readable code review report. All it can do, the only actions it can do is analyze Java source code. And the only goal that it can do is compile, oh, this is the other action, compile analysis into a Java or developer-friendly review report. But to achieve this goal, a human readable code review report. That's it. The agent has 2 things it can do. It can compile, this is one action, compile analysis into a developer-friendly review report, and it can also analyze Java source code. That's it. It can't give you a recipe for apple pie. It can't do anything else other than review code and compile a report. Again, these guardrails, deterministic results. And if I expose this to the world, they can ask it all they want. But the only things it can do is review code. This is the guardrail. So this is how I can have a really powerful LLM, but give it really, really tight guardrails. So we're using Embabel to do this. So again, we're using AI or Spring AI 1.1, but I think we're ready to go. So we're going to give it buggy code to review, and we're going to verify the response. It did that. That's cool. So now, I already kind of looked at this. The code analysis is the type. If we look at this action, the type, this code analysis, that's the only response that it can give. So its output is going to be formatted into a code analysis. Oh, and it can't even find it. Oh, I got to go over here. Here's my domain models, code analysis. It's just a record, right? It's got a summary. It's got a list of issues and a list of suggestions, and then it gives it a quality score. But this is all that I've got to do. I'm just telling the LLM, just like I did my prompt stuffing, I'm telling the LLM, this is the format that I want the result in. So under the covers, Embabel is saying, here's what I want you to do. It's chatting, right? Embabel doesn't know. It's going to chat with whatever LLM we've configured. It's going to do the exact same thing, but it's additionally, it's saying, I want you to format the code this way. And what this Embabel is also doing, it's saying, hey, do I have a path, that goal-oriented action planning? I could give it 1,000 actions, and I could give it a handful of goals, and it'll determine the best route through the actions that it has available to get to the goal that's being requested. Anthony asks, does it automatically do the guardrails for you with wrappers, or is there more things it's doing behind the scenes? So we're just like our chat controller, our chat options that we did in version 1 or in lab 1. With Embabel, we're saying an agent. Under the covers, it's using Spring AI. But what we're exposing with Embabel, the guardrails that Embabel is putting on there, is it only is able to do the actions that we define. This is the deterministic guardrails. So again, I can't ask it for an apple pie recipe. The only things that this agent can do are defined by the actions that we give it. What the LLM, that capability that we're giving, the other piece that Embabel does is, go ahead, ask your question.
Yeah, hello. Yeah, I'm really sorry. I've been having a network issue. So I know I've missed out a lot.
Oh, I couldn't hear you. I'm gonna keep on going. I think things are okay. If you can hear me still, give me a thumbs up. Oh, okay, good. I'm gonna do this. I'm gonna do a quick screen grab.
Oh.
All right, we're cruising. You've got some network problems. Okay.
But then you can go ahead.
Okay, wonderful.
Right,
so, Anthony, yeah, that's the
please, I
guardrails.
would like you to get the reprint.
So Chukwu, could you put your
Please, Mr.
comment
Bishop,
in the
confirm
chat?
if you can hear me, please.
You're cutting in and out still. Can you put it in the chat? Put your question or comment in the chat because yeah, we're having a hard time hearing you still. How do we validate it follows the guardrails? Now here's the cool thing. It's only allowed to do those actions. Goal-oriented action planning, actually, it's a design, it's a pattern, it's an algorithm taken from gaming, right? Where the bad guy has to go and catch the good guy. So the bad guy is going to go whichever path it can find to get to the good guy. But if it changes, right, it'll say, oh, that path didn't work. Let me try another path. So if I had 20 actions here that all could, based on the inputs and outputs, I'm going to go up here and highlight this. The inputs, I'm going to send in a code review request that looks just like this, right? That code review request, that's my input. The output of a code review request is that code review or code analysis. Code analysis. So I'm passing in a code review request and I'm getting a code analysis out. I need a code analysis in order to go into this action. This action takes a code analysis. So here's where we're using that strong type safety that we get in Java. Because if you're using Python to do something like this, if you're looking at the Python frameworks that are out there that are similar, you've got to parse that text. And anytime that you add a new action, you've got to now create a new way to parse that text. Python doesn't have that type safety. Java does. So we're leveraging the type safety in Java to make sure that the only thing that I can pass into this method, not generic text, it has to be in the format of a code analysis. And from that code analysis, I get review report. But I could have another endpoint. I could have another method, another action that also has a code analysis. And then it'll be up to Embabel to determine which one to choose based on the request, based on the goal, on the thing that we're trying to achieve. So that's how we can validate it. And you'll see the tests are doing that exact same thing. So now we have an agent. This agent has two actions and has one goal that it can achieve: produce a human readable code review report. That's it. That's all that this agent can do. It can help us have better code. So we've looked at it. We saw the ins and outs. Now, code review agent using Embabel Scope Planner, you define what the agent can do. We've already seen that. The planner discovers the path automatically. Agent, I'm an agent. I can do this. This is the finish line. Description, I can have more than one action, and I can have more than one goal as well. And I can have the action and the goal in the same endpoint, which we also saw. So the goal-oriented action planning, that same idea. Code review request, I can do the analyze code, I can get a code analysis, and then I can send that code analysis. These documents don't match up. I can send that code analysis to that right report, and I can get my review report. It takes a code analysis and returns a review report. That's how we know that deterministic path through the agent. And if I switch the LLM, it's still going to do the same thing. So here's what we're doing. We're back. We have this safeguard. We have our types or our boundaries. Can I ask the code review for an apple pie recipe? No, not because of prompt filter, because I'm not accepting a recipe. That's not an input. That's not a goal that's going to achieve. So the agent cannot go off script. Every action is declared. The planner only discovers the paths that lead to the declared goal type. If the type doesn't exist, no big deal. I can't do it. This is why I teach Embabel. Determinism is an assistant problem. It's the type system. So we already looked at the domain model, the code analysis, and the review report. And here's the agent actions. So we've already looked at this code. So now we're going to go hit this review endpoint that pulls in the agent and says, hey, do my thing. So let's invoke the agent. Here's the hands-on part. We're going to run it. And then we're going to say, do my thing. We already did the test, MBNW, Spring, sorry. MBNW, Spring, boot, run. Okay, it's up and running. I got to fix the naming. I apologize. But it's up and running. Now we can go. We're going to pass in, remember, that code analysis review. We're giving it the source code. We're giving it the language and the context. So let's copy this. And now our agent's off to work. We've asked it for a review. It's running that Quinn 2.5 model. First thing is Embabel says, do I have a way to give you a review? I got a code analysis request or whatever I called it, code review request, and here's our response. Here's the review. So this specific agent, it did something specific. I'm going to do this again. I'm going to run that command, but I want to pipe it to JQ. Let's do it again. Hopefully we get a little bit prettier view. Same command. I pass in the same code. So here is the review of user service find by ID method. Our agent, using that Quinn model that's 3 or 4 years old now, says, hey, the find by method in the user service class contains potential bugs related to handling invalid input. This is the type of response that you were getting from your IDE, from your Copilot. But what we've done is we've built it. We are giving our agent the exact things that we want it to do. In this case, review our code. Give us best practices, find security issues. That's what we've done. And we can grow this as much as we want. All the cool things that you have inside of Claude and Copilot and Codex, all those cool things, you can customize them. You don't have to rely on their agents. You can build your own agent for your own workflows, for your enterprise or your startup. That's what I'm showing you. Everything that you see out there, Spring AI has giving you the abstractions to do all of the cool things. So now you can imagine your IDE, giving your IDE access to this agent that is just going to, as you're working, it's just going to review where your cursor's at, pass in a little bit of code to the agent and say, how am I doing? Give me some feedback on what I'm working on. So what have we done so far? I'm gonna keep on going. We're cooking with gas. Hey, we asked, we got a good response. We saw that. Oh, I didn't show you the logs on what it's doing. In the logs, we can kind of see, hey, here's my review agent report. Here's my code review request that's coming in. It found the path to the desired goal. That's it. And we got timing. Of course, we have all the observability. We can capture tokens. If we're calling, I could use the same agent to call to Codex, to call to Gemini. I can call the other models as well. Spring AI gives me that ability. But again, the focus on this workshop is we're doing this all locally. We're running a model inside of Docker. We're not giving it any GPU access. We're doing this all locally. And we're getting the exact type of response that you're going to get from the latest Claude Opus. You're getting the exact same quality because it's not as much about what's in the LLM. That's what I've come to find out. It's more about the agent that you're giving it and the harness, the rules that you're providing. That's the bigger value add. So that's awesome. Pythoneers use Pydantic for types, but then it's an extra import. Yeah, it's great that this is natural with Java. Use that type safety. With the local LLMs, how safe is our data specifically with Qwen? I know some of them, there's some outside talking risk, but curious of your thoughts. That's a great question. Anthony's saying, how do I know that the information that I give to my model isn't reaching out to the world? How do I know that it's not sending that, passing along? That's where we heard these sandbox, the idea of having a sandbox. I want to make sure that that agent can't call out to China, right? the nice thing is we can protect ourselves. We can definitely guarantee by not letting that agent call out. We can block external calls. We can separate those things. You notice I had one agent that did the ingest, the one agent that was allowed to call out and pull in information, that was a separate agent. So I can give them different rules and I can isolate. So I don't have to give all the agents all the access. So that LLM never has the opportunity to call home. So that's just one way of building these additional guardrails. Is you don't have to trust that the agent can't call out. But the agent can't call out if it doesn't have the tools to call out. So, good question. And these are the types of things that you should be thinking about. All right, so that worked. We got our stuff. Hey, and the response is that, hey, let's ask for more changes. Fantastic. Just like you'd get a code review, that's what we've done. So what the agent finds is that, hey, I found some equal instead of dot equals, returning null instead of optional. Fantastic. But now we can add a security scan. I'm doing great on time. We can add a security scan. So that same agent, I can say, hey, I don't just want a code review. I want a security scan. I'm going to leave this. We'll come back to this. I'm going to make sure that we hit this last point where we're modifying code. So I'm going to leave this and circle back just in case. This is just the security scan, and most of that is just copy paste. So from the docs, you can copy and paste it into your code. So we have a new flow. Instead of just asking for a code review, I can also ask for a security scan. Here's the key takeaways. Even though we didn't do that second part of Lab 4, Embabel has this goal-oriented action planning planner to connect actions by type signatures. That type enforces those boundaries and gives us a better deterministic result. We know type in, type out. I know what the path is gonna take to that achieves goal. We add these capabilities. I don't have to rewrite the entire workflows. Each action is independently testable with fake operation context. So if you go and look at the tests, I of course added tests because when you change your model, you want to make sure that the model's behavior, its default behavior, doesn't take you down a rabbit hole. So you write your own tests to validate the types in and type out, and Embabel gives you that ability. So also in these tests, you'll notice Embabel using Spring AI 1.1, it didn't have all of the test container things plugged in, so I added that for you as well. So you get the same benefits as if you were using test containers on Spring AI 2.0. You get those same benefits when using Embabel with Spring AI 1.1.1. Back here, domain objects and records, that's the contract, and that's really, really nice. And of course, yes, it was created by Rod Johnson. Lab 5, this is it. Now, this is the grand finale. You put all these things together. I want to build something that does work for me. Don't just analyze and tell me I need to fix changes. Do the work. Let's go in. So first, let's validate it. We're going to go into, not Lab 3, it's Lab 5. I apologize. I'll update those notes. We're going to go over here. We're going to stop Lab 4, right, our code review agent. We're going to stop that one. We don't need it anymore. We're going to go into Lab 5. And we're going to make sure Lab 5 is working. MDNW, whoops. MDNW test. Lab 5 is working. Again, test containers are standing up in the background. So it's running the model, not using the one that we stood up in Docker, but it's using the test container model. So that works. Let's go in. We did our test. The test verifies, hey, it's calling file system tools. So it actually validates this lab is using that file system tool that we created earlier. It's using that tool. Fantastic. The application context loads, Redis and Ollama are reachable. Everything is good. We're in good shape. Here's what we're going to do. No, we're just here on Lab 5. Key concept, connecting to your MCP server. So in Lab 5, in order to use that server, we had to have the URL of that MCP server. And I can have more than one. I can add all sorts of tools for each agent. I can say, hey, yeah, I want to add the URL ingestion agent. I want to be able to reboot the database or do backups. Those can all be different MCP tools, and our agent can decide which one it wants to use when it needs to. That's the key here. I'm not telling the system when to use these MCP servers. Based on the tool's description that we provided, the LLM is going to decide which tool to call. Since we're only supplying the one MCP server, it'll be pretty easy for this one. But be aware, if I've got multiple tools that I'm providing, every one of those tools, it makes the LLM, it makes it decide a few more things. If you want deterministic results, you want to limit the number of tools that you give each agent. Limit the number of tools that you provide to each agent for better deterministic results. Okay, I want those tight guardrails all the way down. So in our properties, let's go and take a quick peek here. I apologize, it says lab 3. This is lab 4. Here we are in lab 5. Let me close all these. In lab 5, source, main, resources. Here's where we load lab 5. We did some stuff for Jackson. There's our Redis config. And then here's our AI connected to Ollama. But I also have here my MCP setup. This is the main thing. Also providing, saying, hey, here's my MCP servers that I want you to have access to, and here's the URL. Embabel configs, similar, same thing. I have workshop docs path, we're in good shape. So that's our config. We've made the MCP server available, and pure Java again. So here's our component. This is another Embabel server, so it's going to have actions and goals. Let's go take a look. Embabel. Here's our stuff. Here's our agent. Our agent is defined here. Developer sidekick that can read, understand, and modify Java projects. Like Claude, right? This is the cool stuff. We've got file system tools, and we have a chat client. Again, that file system tools, that we already configured that. That's an MCP server that we pulled in. So it has that. It also has our chat client. And here's the action. Scan project file system to build understanding of structure and conventions. Very similar to the last one. Another, generate Java code that follows the project's existing conventions. Anthony says, I hear Anthropic is deprecating SSE for MCP servers in favor of streamable HTTP. It seems this is SSE. What's the pattern for streamable HTTP? Let's go back and look. I thought I made that change. Source main. I thought I made it to streamable. I did.
Yeah, so I'm talking about the client calling the server itself. I noticed SSE in the application.yaml.
Oh, maybe I did that wrong. So please hold again. I added this MCP server like the 30 minutes before I got here. So let's go see. Let's go see. You were saying in the config where we call our model, we said file system URL. So this is now the client side, streamable. Maybe my docs weren't updated yet, because the last time we did this workshop, that was SSE.
Yeah, I get. So this is the pattern. I just wanted to see it. Thank you.
Good. Yeah, good eye. Good question. And I don't know if I heard about SSE being deprecated, but I believe you. It seems like I heard something about that, but I don't know any timelines on it. But good question. Thank you. Whoops. I was going, oh, hello. Switching back to our lab 5. We're here. We talked about the agent, sorry. And we saw its ability to generate code, read code. We're doing things. I think it has one more tool available, or one more action that it can do. Now, in these, we're giving it the prompt. In these actions, we don't just say, hey, do this. We can give it additional information as it's doing its work. We're not letting the LLM decide what to do. We can give it specific information, specific rules in the form of prompts to do the work. And we can modify that, right? We can fine tune it so that it meets our needs. Again, staying within the guardrails. This is just saying, here's how we want that report to look. And then we pull out that report. We pull out the code from that report in order to give it that deterministic response, that typed response of generated code. And one more achieved goal. complete a developer task by writing code to the project. That's our goal. This one says write generated code to the file system and report results. So we've made another agent that now can modify code. We have a code reviewer. We have the retrieval augmented generation. We have an MCP server that we can run that can modify code someplace else, right? That MCP server could be running in the cloud. It could be running in my Cloud Foundry instance, where those agents are just running all the time and they have access to a local file system. So this is how we do that agentic swarm approach, where, hey, I've got 5 different things that are working on 5 different projects, 5 different repositories, but I've done it all myself. I've given you all the tools, all the constructs to build your own agents using Spring AI. And this model is a free off-the-shelf model that's 4 years old, and they can still do all this. You don't have to have the latest frontier model in order to deliver really valuable results. The thing that's going to separate us from our competition in the marketplace is how much value can we deliver to our company. It's not, you're not delivering a lot of value if you're burning $1 million worth of tokens every month for work. When Anthony, somebody else, can do the exact same amount of work, but burning $0 in those cloud models. If you can run this model on your laptop like we are doing right now, you can do the exact same stuff. You can design the guardrails. You can tell it exactly how you want to operate. You can feed in your conventions. And you can design these agents to do the work that's going to deliver more value to your company. Pulling this model off the shelf, running it on your laptop. You think about the value. If me and Anthony are delivering the same features, the same amount of code, but Anthony's spending tokens on Claude or on Copilot, there's a difference there. There's a difference. And that's what I want you to understand. That's why I want you to be able to test. You shouldn't have to spend $200 a month in order to do really cool things. We're building it all from scratch using Spring and Spring AI. So let's continue here. Our thing is running. We're in lab 5. We already did the tests, right? We already ran the tests, right? We'll do it just in case. Tests are passing. Everything is good. Love it. So now NW, Spring, boot, run. This is our agent sidekick that knows how to modify code. And we've given it the ability, we've given it the guardrails. You can modify code, but only on this file system from this MCP server that's located someplace else. We gave it the URL. You can talk to that agent. That agent has a hard-coded, here's my path. We're in good shape. So this is, again, this is how the agents work. Strong type in, strong type out. Generate code, I get a generated code. Apply, I get a task result. That's our goal. Gather the project context. I already looked at these. I apologize. I went out of order, but we have our tasks, our actions. The last action is the one that achieves the goal, complete a developer task. So now we're doing it. We're staying it up. And now we're going to pass in. Here's the description. Add a health endpoint that returns JVM memory usage, active thread count, and uptime as a JSON response. Here's the path. Sample project. Here's what we're doing. Generate code. Copy this. Let's go run it. Again, it's just a curl response. Let me clear this. I'm going to send that curl response, and I'm going to pipe it to JQ dot. So it's nice and pretty. So now, what do we expect is happening here? What we expect is, remember, we stood up this file system, MCP server, and that was focused on this code here, this workspace. So what I'm expecting is, I'm expecting to get more code here when it's done. Again, we're running a nice model. Summary, the file implements a REST controller to return JVM memory usage. The file is created, health controller, look at, there it is. We just generated code on a remote workspace. So it's telling us, hey, here's what you can do. But we just did it. Now, if you've followed along, we have done all the things. I've shown you all the constructs on how you can create a really amazing agent. It doesn't have to just be, hey, pull off this new thing, help me go research. You have been given all of the tools to generate your own sidekick. MCP provided that standard protocol so the LM knows how to handle things. We were calling an MCP server that was on another cloud, another place. That MCP server had access to a specific workspace. We could modify this. We could have that agent use our GitHub CLI and go check out a repository. We could do that too. But what I showed you is the constructs. I showed you the underlying pieces for every agent that you've seen. The Spring team, the Spring AI team is ahead of the curve. They have given you the ability to create your own Claude Copilot Codex agent. And I just showed you all the pieces. And I used Embabel because I like Embabel's constructs. I like that type safety that it has, but there's other ways of doing it as well. And the Spring AI community, I'm going to show you, there's a bunch of other projects. We have Spring AI community. These are projects that are not yet, it's kind of like our incubator. They're not yet supported by the Spring team, but they have massive adoption and they have tons of contributors from all the big players. So if you're looking to do anything cool, there's tons of other projects here that give you all those capabilities. I'm a big fan of Embabel because I like that deterministic approach. I know that the agents that I've deployed in my home lab, in my environment, those agents are doing specific things. They're not going to delete my production database. That's a big deal. The tool calling makes it easy. With that tool description, I'm describing to the LLM, here's what you can do. Just the same way with Embabel and the agent's actions, here's what you can do. Here's what I'm trying to achieve. And let the LLM decide which tools, which actions, which route to take. Embabel helps. Path sandbox that, sandboxing. Don't give it carte blanche. Be specific about what you want to do. You might have an agent that's doing your code review. You might have an agent that's validating your code, running the tests and evaluating the test output, looking for anomalies. You can go every which way from here. I've given you all the fundamentals. RAG, GOAP, tools. Each piece is something you built and understand. We talked to an LLM. We brought our own data using retrieval augmented generation. And we gave it tools, file system tools, make actual code change tools. Don't just talk to the LLM. Give that LLM the ability to make changes to our code. Then we gave it a multi-step workflow. Then we had to actually read and write code to our project. Each lab built on top of the other, so you now have the constructs to do amazing things with Spring AI. And whatever LLM you want to pull off the shelf, you don't have to use the frontier models. You don't have to participate in this new token economy. You got a rehab. You got a repo that you can use. You understand the chat client. We've had 2 sessions kind of showing the differences, the system prompt versus the user prompt, giving the chat client tools like that question and answer advisors, right? There's memory advisors so it can keep track of your conversation as well. We did a RAG pipeline for our own docs. We did a deterministic goal-oriented action planning workflow using Embabel, and then we actually integrated that MCP tool and we had it making code changes. AI assisted development, all in Java. It's hot. So we didn't run into any issues. Our issue was it was on the RAG where I didn't have the exercise. I didn't have all the imports. So in this ID, if you're using VS Code, you probably didn't have those. VS Code is able to have more than one Maven project in its workspace. You probably didn't have that problem. But now we can swap out models and you can do it on your own. I'm going to pause. I'm feeling good about the time. That was 1 hour and 40 minutes. And we got through all 5 of the labs in 1 hour and 40 minutes. So I'm going to pause. Yeah, if I were to come back, the next thing I would want to do is I would want to have these agents working together. I'd want to show you how agents can actually spawn off sub-agents to go do things like a code review or to modify code or to go run tests and to validate. That would be the next evolution of this project for me, is I'd want to come back and show agent-to-agent communication. So then you can really imagine how having some infrastructure, having some nice sandboxes with agents deployed. They could be working for you 24/7. My name is DaShaun Carter. I'm a Spring developer advocate. I love my job, and I'm jazzed to be here. This was fun for me. I hope it was valuable for you. We got through a lot. And for those of you that were here last time, thank you so much for coming back. And for those of you that were new, I hope it was valuable. I hope you got something out of it. Let me go back here and look. Anthony says, yeah, the new version of SSE does not recommend SSE. Anthony also says, do you think Embabel will be pulled into Spring AI Core at some point? Seems like a very cool feature. I mean, the Spring AI community has kind of replicated some of the stuff that's in Embabel. I'm a big fan of Embabel. I don't know if it'll get pulled in. I mean, it's ROD, so there's as much, yeah, it's aligned. Yeah, I'll just say that. To get pulled in, I'm not sure. And yeah, I haven't quite used Embabel. Embabel, it's so clean. There's other ways of doing it. I like Embabel's approach, the goal-oriented action planning, because it could actually, let's say it went down. It said I had A to B, B to C, and it had a path that did A to B, B to C. But there might have been another path, went A to B, B to C, and then C to D that meets the same goal. If the first path doesn't work, it doesn't give me my desired result, the goal-oriented action planning will actually back up and try another path in order to get your result. So it's not a one and done fail. What's built into Embabel is, hey, if I go here and that doesn't work, I back up and I look, do I have another route to go? So if I've got hundreds of actions, I'm trying to figure out how to validate a test. Embabel allows me to do that, but I don't have to rewrite. I don't have to know all the possible flows between all those actions. It's the data in and the data out, that type safety that determines all of those workflows. Man, this was fun. So the other thing that I would do for sure, if I were to come back, is make it so the MCP servers required you to authenticate. And I did that in another workshop recently where we talk about security, right? Because now that I made that localhost 8083 endpoint, anybody that has access to that endpoint can be making changes on that file system. So I might want to secure it, right? Especially if I'm going to post it in the cloud. I want those MCP servers in the cloud. So there's another workshop here that I would add in and say, hey, let's not just connect these tools. Let's make it secure connections, because then we can do more advanced things like give it access to some views in our database. Let it go in and actually query the database for the latest inventory, or how many transactions, or what's the current price of Bitcoin. I can give that agent as much flexibility as I want, but I want to do it securely. So that would be if I were to do another session, I'd talk about doing agent context protocol and maybe some agent to agent piping and securing the whole thing with OAuth. I hope this was valuable. If you've got any more questions, we got a few minutes. What do you think? Was it valuable? Thank you, Bright. Are there questions? I have a raised hand. Yes, go ahead.
Yeah, so first off, thank you very much. This was very helpful for me because I've been doing a lot of reading on AI agents and stuff like this with Python, even if I'm a Java dev. So I was very bothered I couldn't find proper materials on doing this with Java. So this was very awesome for me. And then it comments on using open source models. So yeah, in production, you might have to pay for compute. So you want to weigh the cost of doing that versus using API calls and frontier models. So that's my comment. I know you have spoken about it, maybe because I didn't quite come early, but if you could just throw in some thoughts about Embabel. So is it a framework?
Yep.
Is it? Yeah. Okay.
Embabel is an agent framework. And it was created by Rod Johnson. So I'm a big Spring fan. I'm a Spring developer advocate. I'm a big Spring fan. So all of the conventions, all of the way that it's developed, it's very familiar to me. I didn't have to go out and learn anything new. I had to understand actions, agents, actions, and goals. That's the only thing that it added. And by understanding this goal-oriented action planning, understanding that it's type safe, the types in and out That's what determines the different flows, the different workflows. That's it. Everything else, Embabel takes care of under the covers. The rerouting, how to go, which path to take through your actions in order to achieve the goal. Embabel handles that. So it's a framework for writing agents with the goal of being deterministic, having deterministic routes through your workflows.
So at the moment right now, say I am not using Embabel, what is the substitute native to Spring AI that could be used for all the things you used Embabel for?
My recommendation, why I put it in the workshop, is I would prefer you start with Embabel. It's easy, but if you want another path, another way to develop your agents, you look at that AI community here, and there are a couple of other approaches. But again, those aren't a part of Spring AI either. The AI agentic movement is moving so fast, and the Spring team doesn't have enough people to do the proper maintenance of some of these projects. Embabel has Rod Johnson, the creator of Spring, and some other Java champions as well. That's why I lean into Embabel. But if you'd like to learn more about some of the other things in the AI community, in the Spring AI community, I'm happy to deep dive. But my default, my opinion, is I want you to use Embabel because I know the output. I know the results you're going to get.
All right. Thank you very much.
Wonderful. Good question. Anthony said, this was great. Thanks. You've given me more work for the weekend to work on, though. Anthony's from here in the US, and I asked him to come in and give me feedback on the workshop. So I appreciate Anthony for coming in. He's an amazing, and I'm even going to say, like, you should follow him. He's got tons of insights. He works for an enterprise company here in the US. He's really, really talented. Any other questions about anything? So, hey, the workshop's done. Thank you so much. If you've got any other questions about anything, now's your time. Ask me anything. I'm here. I'm going to stop sharing. You've got the URL for the documentation and the URL for the workshop. I will update some of the namings. I will fix the lab so it's easier. What I would love to hear, I would love for one of you to be able to deliver this workshop. That is my goal. That's why I deliver these workshops the way that I do, because you all have a friend that didn't make it here. You all have a friend that might be on your team, that might be on your future team. I want you, a good way to learn something is to teach it. So the way that I set up these labs is for people like you and Anthony to be able to go and take it and run it and describe it and explain it to somebody else. And if you run into something like, oh, I don't understand why we did this, give me feedback. Let's make this repository and all of them, I make them public for a reason. GitHub.com, DaShaun, oops, I'm not sharing my screen. I make these public for a reason. I want you to give me feedback. I want you, like, hey, this didn't make sense. I want you to go out and take and be comfortable giving this. You know what else I'd love? I would love it if you would present it back to me, right? It took us about 2 hours. I'll make it better so we don't spend an extra 10 minutes chasing bugs. But the whole idea is I want you to be able to present this. That's my goal. I want this workshop to be well laid out and to have the right documentation so that you could present it to your friends, your peers. Feel free to take it. Oh, sorry, let me add this real quick. I want to add the license. I typically add the license right away. Let me do that real quick. I'm making it Apache too, so you can take this and present it at a conference if you're comfortable. I would love to see that. And if you do submit this, I'm giving you permission right now to use this repository, even though it's milestones and not GA versions. I'm giving you permission to use any of my workshops. Go out, take it for a spin. That would make me happy. I'm going to add this license. I'll add the license to the repo. Any other questions? That's what it's there for. That's how open source works. That's how we build a community. And it's one of my firm beliefs is code is only going to get us so far, right? With AI doing the things, one of the most important things that I can try to teach you is the value in being able to teach, the value in being able to communicate the work that you're doing. So if you could go and deliver this workshop, even if you just do one lab of the workshop, exercise that muscle of walking through and explaining each of the labs. That's my goal for you. I won't keep you. Any other questions? Thank you, Anthony. Any other questions from anybody about anything? Let me know. Thank you, thank you, thank you. It was a pleasure. It was an absolute pleasure. Can I do this? Can I get you to turn on your cameras and take a screenshot with some like thumbs up? Is that doable? You don't have to turn on your mic. If you can turn your camera and just do like one screenshot, that'd be awesome. If not, that's okay too. Well then, if there's no other questions, thank you so much. The pleasure was all mine.
Wow. Thank you so much, Mr. DaShaun. Thank you very much. Please, can we do well to turn on our cameras as we just have
yeah. There we go. Let's do the selfies. Do a camera shot. The light situation. I get it.
Yeah, you're in Nigeria.
Oh yes. All right. I'm gonna do a screenshot, and I'm gonna do 3, 2, 1, and then I'll take it. So you smile on after one. Ready? 3, 2, 1. Cheese. Fantastic. We got it. That was good. Thank you so much, everybody. I appreciate it. Tell your friends. Feel free to replicate, take it for a spin. And as always, like, I'm available. I'm on the internet. I shared my stuff. Reach out. Right? We don't have to wait for the JUG meetings in order to reach out to me. I try to make myself available as much as possible. So thanks, everybody, again. Thank you so much for your time.
Thank you so much, Mrs. DaShaun. It was an honor to have you tonight. Despite the short notice, you still break everything down into pieces for better understanding. We are grateful for your time and your commitment and your passion. Thank you very much.
That was fun. It went pretty well. We got through a lot, and yeah, and we had a good group. But like I said, I'm happy to come back as often as you'll let me. And yeah, if I were to come back, I'd want to do some agent to agent and some security on top of it. But it would just kind of build on top of what we saw here. So
you're always
thanks.
welcome. Yeah.
Wonderful.
Yeah, you're always welcome. Thank you very much.
Oh, and while I'm here, let me give a shout out to all of the lightning talks. Like, this is one thing that I think this Java user group is doing really, really well. Is you have their kind of regular monthly longer style presentations, but having those lightning talks, oh, that is so nice. Giving people the opportunity to go out and explain. And it does make a difference. And I've commented on some of the blogs that people are sharing. Being able to communicate the things that you're learning is a valuable, valuable part of what I see as the future of what we're going to be doing. The communication is going to be a big part of it. So keep up the good work. Keep doing the blogs and the content. Send me a note if I haven't commented on it. Send me a note directly. And yeah, I'm happy to share.
Thank you very much. Thank you. I'll do that. Thank you. All right. Thank you, Mr. Anthony, for honoring us tonight as well.
Yeah. Thank you, Anthony. I really appreciate it.
All right. Thank you, everyone, for making this section an impactful one. Thank you for your time. Thank you for being there for part 1. Thank you for part 2. We look forward to part 3. So yes.
Wonderful. Wonderful. All right. We'll start working on it. Thank you, everybody. Ciao for now.
Have a lovely night ahead.